All right, so let's see now about this chapter 10, which I always kind of thought would be kind of difficult. But for some kids, it's just a little bit harder. All right, so I'm going to take my time, go slow, go through every little detail. All right, please pay attention. Try not to daydream. All right, get focused in because, again, I think this is kind of tricky for kids. All right, so here we go. It says, well, it used to say, a fruit vendor sells 4 types of fruits every day: raspberries, apples, strawberries, and cherries. The vendor surveyed 30 customers at random. The types of fruit that they preferred are indicated in the following table. If 20 kilograms of fruit are purchased, how many kilograms should be strawberries? Ooh. Anybody have a clue? Oh, good. Tell me. 240. All right. Well, it's all based off of the population who voted, right? So if you were going to buy fruit, look at the votes. What would you buy the most of? Right. Right. And then I would probably buy more what? Yeah, and raspberries and only a couple what? The problem is because I took a survey, or I want to apply that to the 20 kilograms of fruit that I'm going to purchase, right? So out of the 30 votes, how many people picked strawberries? 12. So that's the first thing I want you to write down. 12. Well, first of all, remember, I want you, even though they told us, but the important part was to know the total was 30. All right, the total is 30. So how many picked strawberry as their favorite? 12 out of how many? 30. 12 out of 30. All right. Now I know 20 kilograms doesn't seem like a lot. All right. But that's how much you're purchasing at your store. All right. So how many kilograms? Now, I wasn't sure how she got her original number, but I kind of understand now. But again, all we're doing is taking 12/30ths of the what? Of the total. That's exactly right. 12/30ths of the total. All right. That's what I want like everyone to see. Of in math means to do what? Multiply. So I'm taking 12/30ths times, what was the total? 30. That is it. That's it. Now, come on, we don't need a calculator for that. What happens to the 30s?
They cancel out.
They cancel. So I need a grand total. If I was going to purchase thing, I feel like would be what? 12 kilograms of strawberries.
Mr. Stroud,
Yes.
are we gonna go over the other worksheet?
Yeah.
After
I'm going to look it over. Yes. All right. And you'll see some of the problems down here also. All right. Number 2. Let's see if that was helpful in solving number 2. In a random survey of college students, 136 out of 400 students said they preferred to take 8 a.m. classes. Out of 20,000 college students, how many would you expect to prefer 8 a.m. classes? You should be able to do it now. Tell me what am I going to do? Hold up.
I didn't do it that way.
No, I don't. I want you to ignore him. Tell me what you're going to do.
So I just multiplied them both by 500. Yeah.
Oh, wow. That's a good thing to do.
Got 15,300.
Yeah, I like that. Now, if we want to stay in and proportions is okay, but it's the same principle as this is up here. We had a sample. What was our sample? 136 out of what? Out of 400. Now I can just multiply that by what? 20,000. And that would be my answer. Now he said something very smart. If he wanted to make it out of 20,000, he just knew what to multiply by. All right. But everybody now can take out your calculator. All right. It's the same process, the same process. So now we're just doing 136 over 400 times 20,000. And what did that come out to be? 6,800 students. That would be an approximation. All right. That's how you kind of use surveys on a small scale. So you can see maybe if I have a bigger population, you can see what it actually amounts to. You with me on this?
Yeah.
All right. Yes, ma'am. Tell me. That's the same exact thing. Because literally that's what that fraction is. Do you agree with me? All right. All right. Now, let's see if I taught you anything about probability this week. The spinner is shown below. Determine the probability of each outcome. What's the probability of getting a 6? Yeah, okay, I'm pretty happy with that response. Let's go with 1/8. Anybody have problems with 1/8? All right. Now I need someone to tell me the probability of getting a number greater than 2. Live. 6/8. All right, we would say 6/8 to start out with. I like that. And then we just reduce it to 3/4. I'm okay with that. And now the probability that just says, what's the Davis, hold on. Listen, I'm not sure what the problem is today, man. All right, but get back on track. All right, sit in your chair properly. All right. Let's get back to normal. All right. What? Tell me what the answer is. 5/8. I'm pretty happy with that. All right, is everybody okay with number 5 being 5/8? Okay, now the hard part. Find the probability of spinning an odd number followed by an even number. What do you think? Oh, I like that. 1/2. 1/2. Anybody else? 8/16 reduced to 1/2. I'm okay with that. So it sounds like 1/2 is an answer. Anybody else have something different? Come on, I don't want you to tell me, oh, I had that, but I didn't want to say anything. So, all right, trust me, a lot of people are wrong on these situations. All right, so think about it. What?
Number 6 is 1/4.
Number 6. Oh, confidently, it's 1/4. I like that a lot. 1/4. Why? What did you say? 1/2. Why? That's exactly what I want to hear from you. All right. Anybody else want to explain why they think their answer is correct? All right. Peter has the right answer, the only one with the correct answer. So tell me why.
So it would be 1/4 because half is even and half is odd, but half the time you're getting even, half the time you're getting odd, because it's going to be half of the half if you get an odd, an even, and odd, and odd.
No, it's not. That's exactly correct. All right. I understand your logic, but now we're going to show you mathematically. Please look up. And again, I don't understand, right? You think you know, right? And we talked about kind of this yesterday. How many events are there going to be here? How many events? Find the probability of spinning an odd number and then an even number. There are 2 events. There are 2 events going on. All right. So what I want everybody to do is, and we're talking about this spinner up here. So so I can see it on the screen. I'm going to copy it. I'm going to bring it down here. All right. So we can take a quick look at it. All right. Now, how many events are going on? 2. Now, an event is just something that we're going to do. We're going to spin it, and then we're going to spin it what? Again. So I need everybody to put 2 tick marks down. The first one is the probability of getting an odd number. And what's the probability of getting an odd number? 1/2. You could have said 4 out of 8. All right, but I like 1/2. My second event is probability of getting a what? Even. And that is also what? 1/2. All right. And then we did something yesterday. It's called a fundamental counting principle. Right. We're just multiplying our probabilities. All right. 1/2 times 1/2 is actually what? 1/4. That's why the correct answer was 1/4. All right. That's why the correct answer was 1/4.
So basically, if you spin it twice, 4 times, or if you spin it 8 times, one of the 4 times that you spin it twice, it's gonna be an odd number followed by an even number.
Well, yes, and I really appreciate you thinking about it. So again, everyone should be thinking about it. But here is what he's saying, right? That when you spin the first time, if you did, like, for example, our tree diagram, right? Here's spin 1. All right. You can get either a 1. Now, please, it's kind of silly, but here's kind of how I would like for you to think about it. The first event, I'm going to put right here, number 1. Just pay attention. Look up here on the board. Come on, try. I know it's not the most exciting thing, and I'm sorry. Eventually, next week, we'll be into geometry, and then after that, we'll get into algebra, and algebra is the fun stuff. All right, right now, these are just things I'm trying to help you with do better on the ERBs. All right. So again, event number 1, I can spin either a what? A 1, a 2, a 3, 4, 5, 6, 7, 8. Please just look up. You don't have to be doing anything. There's nothing you can be doing. Just looking up, paying attention, going, okay, that kind of makes sense. So that's event number 1. Does everybody see that? Now I'm going to do event number 2. All right. Now, of course, we don't have to do this. Finley, oh, good for you. I appreciate you writing. Are you writing that down? Is that what you're doing? Good. All right. Those of you guys who like to take notes, that's good. You don't have to, though. All right. Now, event number 2. I can either get a what, or what. I can get 1 through 8. So now let me show you how I'm going to do that. I'm going to take this. I'm going to duplicate it. All right. But I'm going to bring it way down small. All right, I probably can't even see that. But what I want to do is I want to turn it this way so you can see something. Just walk. Hey, God, Davis, come on now. I don't want to start going back to what we did at the beginning of the year. All right. It's annoying. All right, so there's that. Now watch. Duplicate that. Come on, you don't have to write all this out. It's annoying. I'm just trying to show you visually what's happening. So how many different ways were there to spend this thing? How many different outcomes?
8.
Nope. How many total out? 64. That's correct. There's 64 possibilities. What? What? I'm trying to get you focused and you're bouncing around, looking around. I'm not doing it. All right. Now, we want the first spin to be a what?
3 or 6.
Odd. Thank you. We want the first one to be an odd. So that means what's going to happen to all of these right here? What about these? What about these? And what about these? All of those are what? Even. The first spin is a what? Even. So do those count? No, they don't. All right. So now all of these that are not crossed out are odds to start out with. Do we agree? Now I need an odd followed by a what? I need an odd followed by an even. So now I'm going to come over here and I'm going to say odd, odd. That one's out. Do we agree? That one's out. That one's out. That one's out. Does everybody agree? Odd, these are out. These are out. And actually, I could just save myself some time and just do that. Does everybody agree? All of those are out. Now, how many total possibilities were there? 64. And now I'm going to count how many successes there were. Now watch me count successes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16 possible successful outcomes. And what do you think 16 out of 64 is? 1/4. Guess what we said before I did all that work? So either you can map it out, or you can pay attention and say, wow, that's pretty amazing. Or that's what eventually got me so fascinated with math, because it doesn't make sense. But if you list everything out, it reduced down to what? 1/4. So they have proven that will always be true. And then we created shortcuts for you to come up with the answer. All right, is everybody okay with that explanation? All right, that's a really nice way of looking at that problem. All right, so now if you want to find the probability, right, you create the number of events. Here's event number 1, here's event number 2. What's the probability of getting odd? 1/2. What's the probability of getting even? 1/2. What do I do? Multiply, that's your answer. All right, or you can draw your tree diagram. All right, thank you for being patient on that. That was a nice problem. All right, and it's actually very helpful. So now what I'm going to do is I'm going to shrink this down out of the way. All right, now that you paid attention. And I want the answer to number 7. Quietly do number 7. Quietly do number 7. Don't need to flip the page yet. We're on, or is your number 7 on the other page, or is it? Yeah, come on. We're not moving ahead. I'm going to give you like another 30 seconds. And I want everybody, because I've done a great job with this explanation now, everybody should be able to do number 7 and go, wow, this is really easy now. And because I know Finley was listening, I'm sure now he can tell me what the answer is to number 7. What was the answer, Finley? 3 out of 24. Very nice. Go ahead. 1/8. I like that. What'd you get?
1/3.
3 out of what? I like that. 3 out of 1/8 again. Brendan, I thought you said you got that. What did you get? You got that? Come on, good for you.
1 out of 36.
1 out of 36. Very nice. What did you get?
1 out of 512.
What? 1 out of 512. All right, I'm just going to put that down.
3 out of 48.
3 out of 48. Go ahead, Liv. 3 out of 8. You guys are killing me. Killing me. Come on. Tell me. Yeah, you. Why? 3 out of 24. Why? Would you? I'm just going to let you be the teacher. All right. I'm just going to let you be the teacher. Oh, Amaya, tell me. 3 out of what? All right, here we go. Let's get rid of all this garbage. Wait a minute. Make sure I'm getting rid of all the garbage. Cut that garbage. Well, obviously, it was 1 out of 512. I don't know what y'all are thinking. Obviously, it's 1 out of 512. Obviously, I just don't know how to say it any other way than that. Now, the problem is I have one person setting it up like I asked you to set it up, and no one else is doing that. How many events are there? 3 events. So what do I need you to write down? 3 little tick marks. 1, 2, 3. You're amazing. What's the probability of getting a 6? 1/8. So event number 2, what's probably getting a 6? 1/8. And again, 1/8. What am I going to do with my options here? Multiply. I know it's hard with the calculator to do 8 times 8 times 8. I understand that. But just take our word for it. It's what? It's 512. So 1 out of every 512 times you spin that thing 3 times, it's going to come up all 6s. Come on now, we got to get better at it. We got to be getting better. All right, let's have some more fun.
So basically, if you spend it 512, you get 60 times in a row.
1 time, you'll get 6, 3 in a row.
So what if you get like really lucky and you get on the first time?
Well, it's possible to do that because one of them's going to have to come up. You see what I'm saying, right? Like what? Let me ask you this now. Hey, because he's thinking, I appreciate that. And everyone else should be thinking about what I'm saying now. What's the probability they get a 7 and then an 8 and then a 2?
1 out of 512.
1 out of 512. Now you guys are thinking a little bit, right? Now you're thinking a little bit. All right. Very nice. All right.
Any specific number?
Yeah, it's going to be 1 out of 512. Exactly. All right. Now, what if I said to you, what's the probability of getting the same number 3 times? No. What's the probability of getting the same number 3 times in a row?
No, it's not.
Because why?
Wait, what? This is in a row?
Yeah, 3 numbers in a row. What's the probability of getting that?
On 8?
The same number 3 times in a row. What's the probability of doing that for those guys who are thinkers? Tell them. Oh, come on now. Only going to be serious now. You've been smirking and causing me issues all period. Are you thinking or not? So what's the answer? Somebody help him, please. The same number. What's the probability of getting the same number 3 times in a row? So what would be considered a success? Let's do it this way. What would be considered a success, people? Come on.
Getting the same.
So give me a success. What would be a success?
Getting the same number 3 times.
So list them.
Oh,
333. That's an answer. That's 1.
4, 4.
444. What else?
7, 7.
Oh, now it's coming to you. Now it's coming to you. So how many ways are there to get the same number? 8. Thank you. Very good. So it would be not 1 out of 512, but 8 out of 512. And everybody just looks at that and say, well, I can reduce that. I just know that's 1 out of 64. Very good. 1 out of 64. All right. 1 out of 64 rolls, will you get the same number 3 times? All right. Is everybody with me on that? Because out of the 512 different combinations, 8 of them are going to come out 3 in a row. All right. Hopefully that makes sense. Come on now, guys. I like your thinking. Listen to me. Do me a favor. Davis, put that in the garbage right now. All of the stuff, anything that's keeping your mind off what I'm saying, that bottle too, because I don't like that bottle either. Sitting there playing with that bottle like you're crazy again. Regressing back to the earlier days in your 7th grade career. All right. You've been on a roll. All right. Now all of a sudden you're acting like you're in La La Land. All right. Here we go. Number 8, 9, and 10. All right. Carolyn, I like it. What's the probability of getting a red? How did you get that? Wow, the most important thing you need is the total. And the total, she said correctly, was 20. So what's the probability of getting a red again? 7 out of 20. What's the probability of not getting a red? Say it. 13 out of 20. All right, now we're in business. And probability of getting a yellow. I'm listening. Why 0? Nice. 0. Right? Come on, guys. Hopefully you're like, okay, I'm starting to listen, starting to pay attention, starting to make a little better sense. All right. Here we go. Number 11. Let's see how good you are now. A bag of sweets contains 25 gummy bears and 20 orange slices. One sweet is taken at random from the bag. Find the probability that you get a gummy bear. Come on, hold up. I want someone else. Say, what are you thinking on this one? You are amazing, girl. 25 out of 45. And we always must reduce. Say it again. 5 out of 9. I like it. All right, hold on a second. All right. Let's look at number 12. A coin is randomly selected from a jar containing 7 nickels, 10 dimes, 22 quarters. Find the probability that you're not a quarter. Mr. Valdez, what do we got?
Oh. Okay. Total is 39,
Wow, that was quick.
and then not quarters,
Yes.
10. And then
What is it?
10 out of 20.
Because a dime is not a quarter, right? What else is not a quarter?
Oh, and then
Wow, very good. So that would be how many? All right, I'm getting the math flashcards out. 10 plus 7. You are super fast today. I appreciate that. 17 out of 39. Now, it says round to the nearest percent. All right. Generally, all right, I'm going to do our probability as a what? As a fraction. All right. But now take out your handy dandy calculator and let's convert that to a decimal, please. What would be the decimal for 17 out of 39? 0.4 what? 0.43. So we'll just go ahead and say, I'm agreeing with you, 0.436. All right, so then if I said, what percentage would that be about? 43.6%. Is everybody okay with that? Now, the reason why I'm making you do that is because we got ERBs coming up. You need to know a decimal, you need to know a percent, you need to know a fraction. Everybody's good with that? All right, let's do 13 together. Parker rolled a number cube 60 times and the number 3 appeared 8. What is the experimental probability of getting a 3? Come on, who's been quiet today? You definitely not. I said those who've been quiet. Who's going to help me out with number 13?
Me.
Yes, me, go. What would you say the experimental probability for rolling a 3 is?
The number 3 appeared 8, 3 and 60.
I'm just
We rolled a cube 60 times, and the number 3 appeared 8 times.
So what's the experimental probability of
8 out of 60.
Yes, 8 out of 60. All right, and of course we wouldn't just leave it like that.
So,
We would just
4
simplify
out of
that.
30, 2 out of... Oh, no, 2 out of 15.
Thank you. 2 out of 15. All right, is everybody okay with that? All right, number 14. All right. Ms. Vaughn,
So there's 4 dimes and 10 quarters, so you add it and it's 14. So then 4 dimes, so it's 4
Yes. 4/14, which reduces to 2/7. I'm pretty happy with that. All right. I forget, what time does the bell ring, guys? 11. So we still got a good 5 minutes, right? All right, so here's what I need everybody to take a look at now. I would like everybody to try tonight all the way through 27.
And
All right, all the way to 27. Yep, that's your homework. All right, that's your homework. Get started on it right now. All right, I'm pretty happy with that.